The last example I wanted to talk about was formulas where we get equations with fractions with inverse variation. And inverse variation means we have two variables that are changing, and they're x and y. So if you tell me what x is, I can figure out what y is and how they're related. And they're related by that equation, y equals k over x. And the fact that the input is in the denominator makes it an inverse, a reciprocal relationship. And what we can do is, one interesting thing that makes it easy to work with these, to make them not fractions anymore, not rational functions, at least in a lot of the examples, is multiply both sides by x. And so what you get is these two variables, x and y, they multiply to give you k, some constant. I don't know what the number is, but I know that these two, when they multiply, when one increases and one decreases, their product is always k. So in this example in the book, they say, think about the relationship between the length of a string and how fast it vibrates, like a guitar string, and its frequency, how many vibrations it has. So a 26-inch guitar string vibrates at 440 vibrations. That's actually middle A if you're a music person. And so we have this relationship that, whoops, I erased everything. 26 times the length equals 440, or sorry, 26 times 440 equals k. And k has units that are length frequencies, but they're kind of meaningless in a practical sense. K is just this number that talks about the relationship between length and frequency. And it's inverse in the sense that if the length goes down by half, then the frequency has to double, so that when they multiply together, you get the same thing. I don't know yet what they multiply out to be. I didn't calculate that, but I know if my length is cut in half, my frequency has to go up. I have a smaller wire, smaller string, it's going to vibrate twice as fast. Alternatively, if I have a length that's twice as long, a much longer string, it vibrates slower, right? So it gets a lower note, and the frequency is half, because 52 times 220 is going to equal the same thing as 36 times 440, which equals the same thing as 13 times 880. I still haven't figured out what that is, but I know they're equal. So how can I use that to solve things? In the question, they say, well, what happens if I go on the fret and I hold down the string and make it 20 inches, where it's vibrating just on a 20-inch string? Well, what's the frequency there? Well, I know 20 times x has to be the same thing as 26 times 440. So I set that up. And x equals k divided by 20, but k is 26 over 440. And I could do my little calculation, use your calculator, and it turns out it's 572. The frequency is 572 beats per second, right?